Okie dokie. So the title of this talk is Kubernetes Killed the High Availability Star. And you may find that title a little more amusing later once I kind of get into the background. I'm here at the behest of Tembo, which is my employer. We do a bunch of stuff. We put it online. You can do it if you want. We make a lot of extensions. If you've ever used pgVectorize, that's the one I did a talk on yesterday. PgMQ is our queuing thing. It's really cool. If you don't know who I am a speaker. I've been doing this for a while. I wrote a book on high availability. So I kind of have a reason why I'm giving this talk. And it's not because high availability is awesome. Well, it kind of is, but we'll get there. All right, so who here has actually tried to build a Postgres HA cluster? You? Anyone else know what's involved in this? Perfect, you're going to love this then. Yeah, that too. So my social media manager apparently busted up laughing when she saw this picture. This is why Postgres HA is hard. I wrote the book on it. That book is 700-something pages long, and it's almost 2 inches thick. That's the 3rd edition, by the way, so it's probably the biggest one. So why is it hard? This is what I'm going to be telling you for the whole point of this presentation. All right, so these are the parts you need to set up for Postgres HA. And if you're familiar with Postgres at all, you know that the binaries it installs, like there's pgBackRest, pgrewind, you know, all the different little bits and pieces that don't really do much until you tie them together with scripts, right? Postgres is, for whether it's a fault or not, it's just a bag of tools. And it leaves a lot of edge cases. And back in the day, I would say, don't try to build your own HA. Use like Patroni or repmgr or EFM or one of the provided ones where people who work in the industry have tripped over themselves and found all the edge cases and then built a tool to fix them. And then you have to be familiar with lots of concepts, right? Like, how do I architect it? What's Quorum? What's sync? What's split brain? What are network partitions? What's fencing? What's cap theorem? What's PACELC? I call it PACELC because it's funny, right? Just like the first 3 chapters of my book is on theoretical frameworks, theorems, and so you have an understanding of what you're building before you build it. And then we have the tools. Anybody familiar with any of these or most of them? Right? So that's just the HA management stuff. That's not even getting into some of the other components you'll need to kind of glue everything together. And here's the fun part. You get to build it. Even if the tool exists, like EFM, got to configure it, got to plug all the servers together, got to make sure that if there's a failover, you can recover from it properly, so you need to have a playbook for everything. This is the part that sucks. And if you've been a DBA for any period of time, you'll know this, because anything that can go wrong will go wrong. And that's been me on more than one occasion when our HA stack crashed and burned and then also deleted the cluster. Whoops. So that's kind of the intro. How do I fix this? So the common refrain you've probably heard, at least recently, is just use Patroni, right? And I believe this too. It's the best HA tool around right now for Postgres. You know, repmgr kind of got us there, and then EFM from Enterprise DB was another kind of like intermediate step. But Patroni, that has built-in Quorum. It has built-in fencing. It has all the cool stuff in there, right? Okay, let's set it up. All right, let's see. We need to create some servers, buy some servers, set up an RDS or or Google Cloud or Terraform, kind of put the servers, make the VMs. Now we have to install software, install a repo for every one of those tools that I got on the right side here. Do I got all of them? Let's see, Postgres, Patroni, HA proxy, etcd, PgBackRest, and a backup solution. Don't I need monitoring too and some other stuff? We'll get to it in a minute. All right, now let's start configuring everything. Okay, so we got etcd. We've got to set that up on 3 systems. Oh, don't forget the bootstrap phase, because it won't work if you don't do that. Then we have to configure Patroni. That's a big file. Got to do that 3 times, right? At least, because Patroni is a quorum, when that means you need to have 3 of them. And then HA proxy is thankfully simple. You can just copy and paste this one, but it has to be on all 3 systems. Don't forget. I'm being serious here, because the quorum part is the most important element of Patroni. It's what makes it work. But we're still not done. We still have to set up PgBouncer if we want a pool. We still have to set up our backup system, because that's not part of Patroni. That's separate, because remember, Postgres is a bag of tools. Got to combine that stuff together. Monitoring is not part of Patroni either. I mean, it has some kind of built-in things for metrics, but there's no really system. So we need something like a tick stack or Prometheus, or some kind of open telemetry thing we can bolt on. And logs. You're not going to monitor each of your 3 systems individually, are you? No, you got to dump that stuff in Elasticsearch or some other external tool. Also, set it up perfectly. No edge cases. Nothing can fall over in a way you didn't expect. And you need a playbook for setting it up from scratch. Oh, and also any problem you've run into while doing so. And you have to hand it off to a junior DBA or some other person who is not you to maintain it. Good luck. All right. Sorry, I was screwing with you guys. Here's the real answer. So we've got Kubernetes and Cloud Native PG. I love their logos. They're cool. I may have time to get into why I kind of chose Cloud Native PG as the main operator I'm kind of boasting about here. I know the guy who wrote it, so I'm kind of biased. So what is Kubernetes? It's intent. It's declarative. You tell it what to do, and it does it. You don't have to set up everything yourself. You say, I want this, and it says, okay, what should it look like? And then it just goes and does it. The whole point, and this is one of the reasons that Gabriele, the author of Cloud Native Postgres, he kind of sold me all on this. The whole point is you don't have to do any of that stuff I described. You can tell it how it should function, and all the people who designed Kubernetes and built the infrastructure and designed how it all interacts with itself, it does it for you. And it does it in a way that is not bulletproof, but it's very elastic and reactive. This is basically what Kubernetes is under the hood. You've got a control plane and you've got nodes. Your software runs on the nodes. The control plane tells the nodes what to do. That's really what it boils down to. And there's a scheduler and some other stuff that, tell it how to automate things. But the important guy is the control plane. You see that etcd right there? What did Patroni have in it too? So Kubernetes has its own built-in quorum system. So that means, in theory, you could run a Patroni cluster of 1. Because all the stuff that Patroni was handing off to create its own quorum is no longer necessary. I mean, you probably wouldn't have a 1-node cluster, but you could. So these are the 4 parts of Patroni, or of Kubernetes. The control plane, storage, compute, and worker nodes. Storage and compute are separate. That means, and if you've ever played with NeonDB, you can actually assign other nodes to your storage and have like 10 servers for your same data. Not with replicas, but you can do replicas too because it's Postgres. And that's the point. You tell Kubernetes what to do and it builds it for you. And like I said, even if you were using Patroni, it doesn't matter. If you're using Cloud Native PG, it doesn't matter. You can have a 1-node cluster. And you can have a 2-node cluster. These are not something you would normally consider in a high availability situation. But because of the way Kubernetes works, if your node crashes, it'll come back up. Sometimes even before the high availability part, like the operator that watches the systems and makes sure they're all up, notices they're down. Kubernetes will actually, oh, your node just crashed. I'll make a new one and attach it to your storage. And you're done. You didn't even know it was down. Like you may see a blip in your connections, but really that's it. It's better HA than the HA we've been building for like 20 years. So Cloud Native PG, its job is to orchestrate all this. It's the DBA in a box. Whoops, I forgot I named that slide that. So it does all the stuff you normally would have done. Node crash, it'll bring it back up. Need an extra one? Change a line in a configuration file, you now have 3 nodes. You need routing, read and write are both, they both exist. There's also a pool for all your database nodes in case you want to go to all of them. Monitoring logging, built in, is all open telemetry. So you can just dump that straight into a Prometheus endpoint, which you can also host on Kubernetes. Fencing, yeah, of course it's not going to let you connect to nodes that aren't fully online yet. And because it's all kind of hidden in a box, you can't even try to connect to it unless you really know how to get into the system and kind of dig into its guts and like force a connection somehow. So remember all those configuration files I showed you earlier? That's Cloud Native PG. That is a 3-node cluster, each one with a gigabyte of storage, each one with the default, which I think is like whatever the default is defined for that node type, which it could be a 1 gig machine with 1 CPU or whatever the quotas are set up. And sure, you can make a more complex file, but that is all you need to get a 3-node cluster where every single one of those is up. You've got 2 replicas, a primary crashes. It'll probably come up before the system detects that it was down and switched to a failover, because Kubernetes is all about giving you what you asked for. You wanted 3 nodes. And if it is down too long, it takes for too long to reprovision a primary, whatever, it'll fail over to one of the standbys, just like you normally would with an HA system. And then the primary, when it comes back, would be reattached, just like it would, like say with a Patroni system, and it'll rewind it and get it all set up. And if it can't, it'll build a new node, and you'll still have a 3-node cluster. You don't have to do any of that. Normally you would have. So why do all that? I want to get this point driven home if I possibly can. Ephemeral nodes mean you don't have to care what the hardware was doing. Sure, you can do digital forensics, but if you have to go that far, usually there's some other problem in your data. The data is really the part that matters. You need to mount it somewhere, look at what went wrong that caused the node to crash. Because even if you have hardware, if the hardware shuts down, if it does whatever, you have to bring it back up. Virtual machines are the same. Containers are the same. If they are born ephemeral, they don't matter. Your data is what matters. Declarative results focus on the result, right? If I tell a system what I want, it should build it for me. This isn't exactly AI, like it's not an LLM, it's not interpreting my instructions. We have a definitive config file syntax. But that's not really important. It does what I tell it to do. I'm the DBA and I'm saying, okay, I want 3 nodes, I want them to do this, I want it to fail over out of these parameters, I want it to have storage here, backups should go to S3. I can just define all of that and it will make sure it happens as long as I didn't screw up a token somewhere and make sure my authentication was proper. Your storage is what matters, always. With Postgres, with any database, the storage is what matters. It's not ephemeral, just the compute is, which is how NeonDB works, for example. So there are other operators. I'm not just going to say Cloud Native Postgres is the only one, but I will say that all the other operators are basically just wrappers for Patroni. Every last one of them except for Cloud Native PG. That's why they called it Cloud Native PG. They wrote it from the ground up to only pull Kubernetes levers, to only build Kubernetes native objects, to only use Kubernetes built-in functionality. It's the next stepping stone to cluster native everything, right? Because eventually we're going to have compute and storage connected only by networks, and what we think of as a computer will be completely different. Like just the same way you can plug in a new hard drive, or you have four CPU slots on a really big motherboard, you can just plug and play components. That'll be what computers are in the future. Kubernetes will get us there because the workloads, they're ephemeral. They can move from one node to the next, one network to the next, right? It's the system that makes that happen, and eventually, maybe the next couple decades, that's what everything's going to be. You put two of these node workhorses in your basement, put a workload on them, you're done. So these operators, like I said, and it's funny, some of them are actually forks of each other. They're all just Patroni. And do you like the naming scheme? We've got the Zalando Postgres operator, the Crunchy Postgres operator, the Percona Postgres. Like they don't even give it a name. They just say, it's an operator. Because, I guess at the end of the day, that's all it is. But, and then we have StackGress from OnGress because they just take a word and add gress to it. And then KubeDB is like it works with multiple database systems like SQL Server, MySQL, whatever. I just added it to the list because it came up in a lot of my searches for other operators. So that's all I've got for you. I went through my slides really fast because it's only 20 minutes. I could have spent 3 times longer if you really wanted me to. And if you want to grab me after the presentation, you can. And at Tembo, we let you set up all this stuff on our Kubernetes cluster running in AWS and also Google Cloud and also Azure. I think we're adding that now. And our stacks let you build like AI stacks. Like it has all the extensions that you'd normally see, like pgvector, pgvectorize, pgmq, or geospatial adds PostGIS and I think pgpartman and pgcron and other stuff that you normally use in kind of an automated setup. And then you can get a free trial, which gives you like $300 worth of AWS credits to set up a cluster. And if you don't use all that in the month and don't renew, it'll give you a hobby tier, which is our free one. But be careful, that one shuts down if you don't connect to it after, I think, 24 hours. It like goes into a pause state. You have to log back in and turn it back on. So that's all I got for you. I hope you enjoyed, and Kubernetes for life.